Hi, today we are diving on the Lewis structure, which is also known as the chemistry version of a group selfie. So think about Lewis structure as a molecular matchmaking. Here we can see who bonds with whom and who just prefer to shell with a lone pair. So the Lewis structure is the diagram that shows bonds between atoms and also show the distribution of the valence electron around these atoms. So this structure is very important. Why? Because first we can predict the molecular shape and the geometry. Second, we can determine the bond order. Is it single bond, double bond, or triple bond? Also, we can know the reactivity of this molecule. So, before we start drawing this structure, there is two important key concepts that you have to remember. The first one is the valence electron, and the second one is the octet rule. The valence electron is the electrons located on the outermost shell. The octet rule is the rule in which the atom tends to bond to form 8 electrons surrounded. Of course, there is exception for this rule, and we're going through these exceptions on this session. Okay, so drawing the Lewis structure. Drawing is like a setup of atoms to a team photo. For this photo, each atoms need their spot, their bonds, and their ion plane to be placed. Okay, there are 3 main steps that we have to follow to make sure that this structure is the correct one. The first one is determination of the valence electron, total valence electron that exists for all the atoms on this molecule. The second step is choosing the central atom for this structure. The third step is like start drawing bond between these atoms. But we have to make sure that the electrons are adding up according to the first step. Okay, let's take an example and see how can we apply these steps to draw Lewis structures. So the first one is CH4 methane. So the first step, we have to determine or calculate the total number of the valence electron on this molecule. So carbon, the valence electron for this carbon atom is 4. Why we said 4? Because it's located, this element is located in the group number 4 on the periodic table. So what about hydrogen? The valence electron is 1. And because we have 4 atoms of this hydrogen, so this 1 valence electron will be multiplied by 4. So it will be 4. 4 plus 4 equal 8. So the total valence electrons will be 8 electrons. Okay, so the first step is tick. The second step is choosing the central atom. So the central atom here, it's obviously you can say it's a carbon because it's surrounding, there is 4 hydrogens surrounding this atom, and that's correct. And in general, if you have a carbon on a molecule, so usually the carbon is always the central atom for this structure or for this molecule. So what about if I have a molecule and I want to draw or to determine the central atom of this molecule, but there is no carbon atom exists. So on that case, so choosing the central atom will depend on the electronegativity. So the least electronegative atom will be the central atom on this structure. So the central atom will be carbon, surrounding by 4 hydrogen atoms. Okay. So Now we're choosing the central atom, stick. We now start to draw the bonds between these atoms. So there is bond electrons here, an electron here, that's form bond, because as we said before, that the line which you represent, the bond, represent also two electrons. So dots here and dots here can form the bond, which is draw it as a line. So at the beginning, you may use the dots to to draw the bonds, and with time or more practice, you will use the line instead of drawing dots. So let's do it here. So that will be another bond, a third bond, and fourth bond. Okay, so we draw the bonds between these atoms, but we have to make sure that the electrons is adding up. So let's see how many electrons on this structures. 1, 2, 3, 4, 5, 6, 7, 8. So this is the electrons which is adding up is 8, which is the same as the calculated total valence electron. So that's right. So this is the right Lewis structure of this molecule. If you want to apply the octet rule of this one, we can see that this atom, the central atom, is surrounding by 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So it's also obey the octet rule. And you can see here the carbon atom is this is a perfect photo for this molecule. The carbon atom is happy, surrounded by 8 electrons, and everyone is happy with this structure. So let's have another example. P, phosphorus trichloride. The same, we will follow the same step. So the first one, calculate or determine the total number of the valence electron number of this molecule. For phosphorus, the valence electron, because it exists on the group number 5, so the valence electron will be 5. Chlorine is from the halogen group, which exists on the 7th group, so it has 7 valence electrons. And because we have 3 atoms of the chlorine, so 7 will be multiplied by 3 equal 21. So 21 plus 5, so the total number of electrons will be 26. So the first step, click, we finish. Choosing the central atom. Here in this molecule we didn't have carbon. So that means that we have to choose the central atom according to the least electronegativity of this atom. Which atom has a least electronegative on that case? Phosphorus. So if we draw the phosphorus here is the central atom, and the 3 chlorine atom is surrounding this central atom. As we said that the chlorine is a halogen from the halogen atom element, so it will be surrounding by 7 electrons or valence electron. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so, and we start to draw the bonds between these atoms. Here is that. So, first bond, second one, and the third one. Okay, so now we have to make sure that the electrons is adding up. So let's start with this part. So how many electrons in this section? 1, 2, 3, 4, 5, 6, 7, 8. So each part of these has 8. So 8, we have 3 parts, so 8 times 3 equal 24. But so that and 24 is not the same as 26. So there is a 2 electrons that has to be added to this structure to be drawing correctly. So on that case, 2 electrons, the remaining 2 electrons will be added as a lone pair on the phosphorus atom, like this. So now it's the correct one by adding these two electrons as a lone pair. Okay, let's go to the third example. Water, so H2O. Okay, again, we have to determine the total valence electrons of these atoms. For oxygen is 6. Hydrogen, valence electron is 1, and because we have a 2 hydrogen atoms, so 1 times 2 equal 2, 2 plus 6, so the total number valence electrons will be 8. So second step, choosing the central atom. Here, which one is the central atom? Again, the central atom is the atom that has the least electronegative. So in that case, it's oxygen. And as you can see, we have a 2 hydrogen, so it's each hydrogen in each side. So this hydrogen here, and this is the other hydrogen is here, and bond here, and bond here, bond here, and bond here. We start drawing the bonds between the atoms. Okay, and because hydrogen is surrounded by 6, so there is a 2 lone pairs of this one. Why? Because this is 1, 2, 3, 4, 5, 6, right? So this is the 6 valence electrons of the oxygen atom. So let's try to see if the electrons is adding up or not. So count 1, 2, 3, 4, 5, 6, 7, 8. Exactly. So the adding electrons is right according to the first step, which is showing the total valence electron is 8. Sorry. Okay. If you see here, we have 2 lone pairs. So if atoms has a lone pair and it's more than lone pair, so it can form one bond with the other, and the other lone pair is surround the atom, so it can just form one bond and surrounding by other lone pairs. So if this element or atom will tend to form a double bond, so in that case we only have a 2 lone pair. In case of this atom tend to form a triple bond like this one, so in that case this element or this atom, it will have only 1 lone pair. Okay. Okay. So let's talk about carbon dioxide and see how we're going to draw it. Okay. So the first step, calculating the total valence electron. Carbon has a 4 valence electron. Oxygen has 6 valence electrons, and because we have a 2 oxygen atoms, so 6 will be multiplied by 2, so 12 plus 4. So the total number of valence electron will be 16. Okay. So the second step, choosing the central atom. So on that case, carbon exists, so the carbon will be the central atom, which also it has the least electronegativity of this one. So carbon here is the central atom, and there is 2 oxygen, each oxygen atom in each side. So another oxygen here and another oxygen here. Okay, let's draw a bond between these atoms. So oxygen is surrounding first by 6 electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there is one, the carbon is 4 valence electrons. So 1, 2, 3, 4. So start drawing the bond. So there is a bond between the carbon atom and the oxygen atom. Also, there is another bond between the carbon atom and the other oxygen atom. Okay, let's see if the electron has adding up or not. Okay, so 1, 2, 3, 4, 5, 6, 7, and another one, 1, 2, 3, 4, 5, 6, 7. So this part is 7. 7 times 2 is 14, and there is another electrons here, one here and one here is 16. Yeah, that's true that this number or electron adding is the same as the total calculated valence electrons, but as we can see that this is not, carbon is not happy. Why is not happy? Because it's not surrounding with 8 electrons. It has only 1, 2, 3, 4 electrons, so it doesn't obey the octet rule, so it's not happy. So in that case, what we have to do, there is a double bond will be formed in that case, and that electron will be here with that electron to forming another double bond. So the structure, the final structure will look like this one, oxygen here, and there is a double bond, Okay, and let's see if we have the octet rules has been obeyed for this central atom. See, the carbon has surrounding by 1, 2, 3, 4, 5, 6, 7, 8. So it's happy. And the oxygen here also surrounding by 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and the same on the other side. So if you notice here that, as I just mentioned that if atom has a lone pair and she preferred to, or she tend to form a double bond like these double bonds, so it will have 2 lone pair remaining. Okay? Let's take another example. Methanol. Okay, the first step is calculating the total valence electron of the all atoms. The carbon is 4, and hydrogen is 1, and because we have 3 atoms here and 1 atom here, so the total number of hydrogen atom is 4, so the valence electron, this valence electrons will be multiplied by 4, and the oxygen is 6, and let's calculate all these together. So this is 4, and this is 4, and this is 6, so it will be the total valence electron of this molecule will be 14 electrons, valence electrons. Okay, the first step has been done. So from this structure or from this molecule, you can say that these 3 hydrogen is connected to this carbon, and this hydrogen is connected to this oxygen. So if we just draw it like this, so the carbon atoms is surrounding by 3 hydrogen, and this oxygen atom is like bonded with this hydrogen. Okay, on that case, what's the central atom? So we have, of course, we have carbon, and because it's the least electronegative atoms, and so it's here, and we also have the oxygen, another central atom for this molecule. Okay. So let's draw the bonds between these atoms. So here is a bond, which is 2 electrons, another bond. So this is the part of CH3. And there is a bond between the oxygen and carbon. So we have also there is a bond, and hydrogen oxygen also there is a bond, and because the oxygen atom here forming two single bond, so that means the remaining lone pair of this oxygen will be two lone pairs. Okay, let's see if the electron is adding up or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is exactly, the same electrons is adding up to the same electron that Ben calculated for the valence electrons. The other thing is these central atoms obey the octet rule. Let's see. The carbon here is surrounded by 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So it's happy. And the oxygen atom, which is another central atom for this molecule, is surrounded by 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So the central atoms of these molecules obey the octet rule. So what about this structure? So again, calculating the electrovalence of these structures for carbon, we said valence electron is 4, and because we have a 2 carbon here, so 4 times 2 equal 8. Hydrogen, valence electron is 1, and because we have 4 carbon atoms, so 1 times 4 equal 4. For the oxygen atom, the valence electron is 6, and we have only 1 oxygen atom. So by adding all these electron valence to calculate the total number of the valence electron, so it will be 8 plus 4 plus 6 equal 18 electrons. Okay, so the first step has been checked. The second one, choosing the central atom. So the central atom, what do you think will be the central atom in that case? Of course, when we see carbon, so this will be the central atom. So the first carbon will be the central atom. Okay, and this carbon is surrounded by 3 hydrogen. 1, 2, 3. So if this is the only central atom that we can find, no, there is another central atom, which is also carbon, because carbon is the other carbon atoms. If you want to compare between these 2 atoms, carbon or oxygen, which one will be the least electronegative? So in that case, the carbon will be the other central atom because it is a least electronegative atom compared to that oxygen one. So the oxygen, so here is this carbon is connected with oxygen and hydrogen. Okay, so let's draw the bonds. So from carbon to hydrogen there is a bond, and there is another bond for the other hydrogen, and another bond for the third hydrogen. Also there is a bond between these 2 central atoms, so there is a bond here, and between carbon and hydrogen there is another bond, and between carbon and oxygen there is another bond. Don't forget that the carbon has a 6 electron pair, valence electron, 6 valence electrons, 1, 2, 3, 4, 5, and this is the 6th one. And let's draw, after drawing the bonds, we have to make sure that that the electrons is adding up. So let's start with this part. So carbon and hydrogen, how many electrons here in this bond? There is a 2. And how many the same, like this bond, the same bond is like repeated here and here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so that will be 12, adding up. And because there is the oxygen we put surrounding by its valence electrons, so it will be included on this adding up. So 13, 14, 15, 16, 17. So there is a missing electrons that must be added here. So on that case, so these electrons will form another bond with the electron which is here, because we said that the carbon atom has 4 valence electrons, 1, 2, 3, 4. So this electron with this electrons forming the other double bond. And let's see if this central atom obey the octet rule or not. So the first carbon atom is surrounding by 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So it's happy, it's obey the octet rule. The other central atom, which is carbon, here, and let's see how many electrons it's surrounding with. So 1, 2, 3, 4, 5, 6, 7, 8. So also this central atom is obeying the octet rule. Okay? So okay, as I mentioned at the beginning of this session, that when I talked about the octet rule and say that there is an exception of this rule. So of course there is an exception. So what's the exception of octet rule? Exception, we have 2 exceptions of that one. 2 exceptions. The first one is incomplete octet rule, incomplete octet rule, and the other one expanded octet rule. So let's talk about the first one, the incomplete octet rule. When I say incomplete octet rule, because we know the octet rule mean 8 electrons surrounding the atom. Incomplete, so that means the central atom of this atom is surrounded by less than valence electrons. For the expanded one, we see expand. Octet rule, so it doesn't have only 8 electrons or 8 valence electrons surrounding this one, but it has more than 8 electrons surrounding this atom, and this atom is happy. Okay, so let's take an example and see how can we draw the molecules that has exception of the octet rule. So we have here boron trifluoride. So we will follow also the same 3 steps, main steps of Lewis structures drawing steps. So the first one is boron. And what's the valence electron of this one? Boron exists in which group? So the boron exists on the 3rd group, so it will be 3. Fluoride halogen exists in the 7th group, so it has a 7 valence electron. And because we have a 3 of this fluoride atom, so it will be 7 times 3 equal 21. And 21 plus 3, which is the total number of the valence electron, it will be 24 valence electrons. So the next step, choosing the central atom. On that case, if there is no carbon, so the central atom will be the least electronegative atom. On that case, the boron is the least electronegative atom. And this boron atom is surrounded by 3 fluoride atoms. And fluoride from the halogen is surrounded by 7 electrovalence. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now draw the bonds between these atoms. So first bond, second bond, and the third bond. Okay, let's make sure that the electrons is adding up. So 1, 2, 3, 4, 5, 6, 7, 8. So this part is 8, okay? And we have the same part repeated 3 times. So 8 times 3 equal 24 valence electrons, and this number is the same with the total valence electron that has been created on the first step. So the boron here is happy, although it doesn't obey the octet rule. It has an incomplete octet rule. So you can see, to know that, so the boron electrons is surrounding by how many electrons? 1, 2, 3, 4, 5, 6, not 8, but still happy. So this central atom didn't obey the octet rule, but is still stable and happy. Okay, and instead of doing this part, these sections, you can, if you're not familiar with it, because with time and more practice, you will know how to just calculate fast the electrons to make sure that it's adding up. So instead of this step, what you can say that just count the electrons on the normal simple way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and this is 24. Okay, so this is the first type of the octet rule exception, which is incomplete one. What about the expanded one? So the expanded one, no, sorry, I would. As I said, the expanded one means that the central atom didn't obey the octet rule, not have only 8 electrons around it, but also it has more than 8 electrons, and it's stable and happy. So let's draw this structure and see if it's obey or not. Phosphorus, the valence electrons is 5. Chloride, the valence electron is 7. And because we have 5 atoms of chloride, so we have 7 multiplied by 5. So this is a 35, and this is a 5. So the total number, the valence electron number, will be 40 valence electrons. Okay, so choosing the central atom. In that case, the central atom is the one that has the least electronegativity. So if you look on your periodic table, or you can see here that according to that one, so the fluorine is in the group number 5, the phosphorus in the group number 5, and chlorine in group number 7. So phosphorus is less electronegative than chlorine. So it will be the central atom. And here we can see this phosphorus atom is surrounded by or bonded to 5 chlorine atoms. 1, 2, 3, 4, 5. And as we mentioned before, the chlorine is a halogen, is surrounding by 7 electron volts. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And here also the same. Okay, so let's draw the bond between these atoms. So there is a bond here, the first bond, second bond, and third bond, fourth bond, and the fifth bond. Okay, let's see if the electrons is adding up or not. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So this part is 8, and we have 5 parts have the same number of valence electron. 1, 2, 3, 4, 5. So 8 times 5 equal 40. 40 electrons exist on this molecule, so valence electrons. So what about the central atom? Is it obey or there is an exception? Let's see. The phosphorus, surrounding by how many electrons that this phosphorus atom is surrounded with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it's stable and happy. So this kind of molecules didn't obey the octet rule. It has expanded, this kind of the exception that it happened here. So it's expanded octet rule. Okay? So another example. Okay. The xenon exists in the 8th group, so it has 8 valence electron. Right. The halogen group, so it has a 7, and because we have a 4, so fluoride has a 7 valence electron, and because we have a 4 fluoride atom, so we multiply by 4. So 7 times 4 is 28 plus 8, so the total number will be 36 valence electrons for this molecule. So what about the central atom here? The central atom will be the xenon, and there is a 4 fluoride atoms bonded to this one. Okay, so start drawing the bonding between these atoms. So first one, second one, third bond, and the fourth bond. Okay, we have to make sure that the electrons is adding up, as we mentioned in the previous examples. So let's start with this part. 1, 2, 3, 4, 5, 6, 7, 8. And because we have 4, it's repeated, this section is repeated 4 times. So 8 times 4 equal 32. Wow, 32, it's less than the calculated valence electrons. So what we have to do, so there is a 4 electron missing that must be exist on this structure or this molecule. So these 4 missing electrons will be added to the central atom as a lone pair. One, 2, 3, 4. So this is the 4 missing electron that will be added to 32 electrons, and the total will be equal to the calculated total valence electron. Okay. All these examples that we study is about drawing the Lewis structure for molecules. So what about if I want to draw Lewis structures for ion, either positive ion or a negative ion? So is something will be changed from these 3 steps that we always follow to draw this structure? We will see. Okay, the first example is ammonium ion. Okay, so first step, determine the total number of valence electrons exists on this ion. Nitrogen, the valence electron is 5. Hydrogen is valence electron is 1, and because we have 4 hydrogen atoms, 1 times 4 equal 4. On that case, if we are going to draw the valence electrons for an ion, whatever the positive cation ion or the anion ion, we have to take in consideration the type of charge that this ion have. So because it has a positive charge, so by adding these valence electron 5 plus 4, we have subtract this 1 electrons, so the total number will be 8 electrons. Okay, as you can see, because this is the stable composition of this ion, because we never have the electrons in the odd number, we always have it in the even number. So imagine that we didn't add this or subtract this electrons. From the 9 electrons, so the total number will be 9, so this is wrong. So from this step you can see if this step is wrong or not, because if you didn't recognize this mistake, so the whole steps will be wrong. Okay, so now we calculate the total number of valence electron exists on this ion or in this structure, and taking in our consideration this cation charge, we subtract it from the total number to make sure that the calculation is correct. The second step is also the same, is choosing the central atom. Here in this case the nitrogen, because it's the least electronegative atom, it will be in the middle and surrounding by 4 hydrogen. 1, 2, 3, 4. Okay, and see now we have to start drawing the bonds between these. First bond, second bond, third bond, and the fourth bond. So is the electrons is adding up? We will see 1, 2, 3, 4, 5, 6, 7, 8. So the N atom, a nitrogen atom, is a central atom, obey the octet rule, and it's happy and satisfied with these 8 electrons surrounded. But on that case, if we are going to draw the lowest structure, and this is the lowest structure for this is talking about ion, so you have to make sure that there is a sign here. You have to put the sign, put the structures inside the brackets and put the sign outside the bracket. Now we take another example of ion and see how can we do it. ClO4 minus. At the same, we have to calculate first thing. We have to calculate the total valence electrons. For the Cl is halogen, 7 the valence electrons, and for oxygen is 6, and because we have 4 atoms of oxygen, so 6 times 4 equal 24. And now we are drawing a structure. We're drawing a structure to a charge or the ion. So we have to take in our consideration this charge. So 7 plus 24 plus 1. So it will be, this is 31, 32. This will be 32 valence electrons. So the central atom in that case will be the chlorine, because it is the least valence, negative electronegative atom. So it will be here, chlorine, surrounded by 4 oxygen, and as you said that oxygen is like has a 3 lone pair if it's preferred to form 1 bond. Okay, now we have to draw the bonds between the carbon and the chlorine and oxygen. 1, 2, 3, 4. Okay, so and have to make sure that the electrons are adding up. So we have to count all the valence electrons on this drawing structure. 1, 2, 3, 4, 5, 6, 7, 8. So this part is 8. So and we have 4 parts. So 8 times 4 equal 32 electrons. It's exactly as the calculated one, but that's it. No, we have to remember that the ion structure should be drawn between, or should be put inside the brackets, and the charge of this ion should be outside, either negative charge or the positive charge. And that's it. Thank you so much for your listening, and it looks like it's different. It's difficult to remember it or to keep all this information in your mind. But with more practice, more different example, you will see it will be much more easier and will not take time to just draw this kind of structure. Thank you.